Hello student, welcome to the subject of microcontroller. This is Professor Meenakshi Panchad, Electronics and Telecommunication Department, Parvatibai Ganba, Moje College of Engineering, Wagoli, Pune. So in last class, we have discussed about basic information about microcontroller, introduction, advantages and few applications we have seen in last class. So today we will go through the basic of microprocessor, how the microprocessor is differentiated from the microcontroller. So from last class, we have observed that microcontroller itself have a microprocessor, but now see what's the microprocessor. So let's start. So microprocessor is a central processing unit of the general purpose digital computer. So here I have mentioned in the figure, microprocessor itself a general purpose unit. They can address the address of memory to operate. It consists of ALU, accumulator, working register, program counter, stack pointer, clock, interrupt circuit, etc. But in microcontroller, all these things are inbuilt with these external devices. Here are some few devices like a RAM, ROM, IO port, timer, serial and ports. Serial communication ports are interfaced externally to the microprocessor. But in microcontroller, they all are fabricated on a single chip by using CMOS technology. But in microprocessor, we should have to interface externally using the bus to exchange the information from one device to other. The microprocessor alone is not a complete digital computer, because it's in order to make a complete computer, one should add memory like a ROM, RAM, EPROM and PROM. IO devices, so many devices we have to interface externally. Few examples of the microprocessors are IC8279 and some more programmable peripheral interface devices had to be interfaced to the microprocessor to make a complete digital computer. Here the few of the devices I have mentioned in the figure, we have interfaced external to the microprocessor by using a data bus. The data bus is used for exchanging the information and address bus is used for accessing the memory of the particular memory by using the address. So address will be provided or accessed by this address bus. So here are some of the examples of the microprocessor, that is Intel 86, Motorola. There are many ICs of microprocessor. So let's see about microcontroller. So microcontroller is a small computer which is having inbuilt RAM, ROM, IO ports, timers, interrupts, etc. These all are fabricated on a single chip by using a CMOS technology. In order to avoid these due to the varieties of memory and IO devices, the hardware design of the microprocessor is arranged so that a very small or very large system can be configured around the CPU depending on the applications of the user. For small application, the minimum size memory and IO must be interfaced to the CPU. This increases the hardware and it turns the PCB size and cost of the system also increases. So this is one of the drawbacks of the microprocessor. In order to avoid these drawbacks of the microcontroller, we have developed the microcontrollers. In order to avoid these drawbacks of the microprocessor, we have developed the microcontroller. Microcontroller itself a small chip. It optimized for the specific application. It consists of all the features of the microprocessor as well as the features required to build a complete computer. The microcontroller has on-chip peripheral device. They are ROM, RAM, serial I/O ports, parallel I/O ports, timer and counters, interrupts, and clock circuits. These on-chip peripherals make it possible to house single-chip microcomputer system. So all the devices are fabricated on a single chip. Here we have mentioned this is rectangular shape indicates the small chip itself. All the devices fabricated. So let's see the difference between microprocessor and microcontroller. Here, first of all, we have seen the difference by using the figure. Here, it's a microprocessor architecture. Microprocessor is itself having a CPU. The CPU consists these things: accumulator, arithmetic and logic units, working register, interrupt circuits, stack pointer and program counter, timing, and clock circuits. But microcontroller, which is having these things, which is having microprocessor and externally and also having memory, serial, interrupt, timer circuit itself. The performance of microprocessor is very flexible. According to the application, the microprocessor is designed, but the microcontroller is designed for the single and specific application. The microprocessor contains ALU, general purpose registers, stack pointer, program counter, timing, control circuits, and interrupt circuit. A microcontroller contains the circuitry of microprocessor and has the built-in RAM, ROM, I/O devices, timer, and counter. It is suited. Microprocessor is suited to the processing information in a computer, but the microcontroller controls the I/O devices requiring the minimum component of the count. The microprocessor has 1 or 2 bit manipulation instruction. Here the microcontroller has many bit manipulation instruction. Microprocessor has less number of multifunctional pin. The microcontroller has more number of the multifunctions pin. Microprocessor have large memory address space and more data, but the microcontroller have relatively small address spaces and less data. Microprocessor has a single memory map for the data and code. Microcontroller has separate memory map for the data and code. The designing of microprocessor is very flexible, but here in the microcontroller, it's designed for the particular application only. So the designing is less flexible comparing to microprocessor. The microprocessor based system requires more hardware. The microcontroller based system requires less hardware, reducing the PCB design size and increasing the reliability. The access time for memory and I/O devices are more in a microprocessor, but the less access times for the built-in memory and I/O devices in microcontroller. The clock rate are very fast. Here the clock rates are relatively slow. Microprocessor has many instructions to move the data in between memory and CPU, but the microcontroller, which is having 1 or 2 instructions to move the data in between memory and CPU. The microcontrollers are very expensive comparing microcontroller. Microcontrollers are cheaper. So these are some difference between the microprocessor and microcontroller. So let's see next classification of microcontroller. Let's see the classification of microcontroller, how the microcontrollers are classified. Here the graph shows how the microcontroller classifies based on bits, memory organization of the devices, based on instruction set, memory architectures, and family of the microcontroller. So let's see one by one. The microcontroller is classified based on the bits. There are varieties of microcontroller, operates on 8-bit data, 16-bit data, and 32-bit data. The microcontroller used to execute the arithmetic and logical operations like addition, subtraction, multiplication, division, and extra on 8-bit data. So those 8-bit data processor microcontroller, those 8-bit data on that the microcontroller processes, that microcontrollers are called 8-bit microcontroller. Similarly, the microcontroller used to perform the arithmetic and logical operations of all the operations like a addition, subtraction, multiplication, and the logical as and or many operations performs on 16-bit data. So that microcontrollers are called 16-bit microcontroller. These 16-bit microcontroller performs higher accuracy than the required. The microcontrollers uses in automatically controlled applications are 32-bit. Those operates on 32-bit data. So usually 32-bit microcontrollers are used for medical and automatic applications. So next is see the microcontroller classified based on the memory. Here there are two types of memory: external memory microcontroller, embedded memory microcontroller. So external memory microcontrollers are those microcontrollers which are designed in such a way that they don't have a program memory on a chip. The microcontroller which does not contain inbuilt memory on the microcontroller, such microcontrollers are called external memory microcontroller. Embedded memory microcontroller, those are such microcontroller, they are designed in such a way that they have all the program and data memory on a chip. So those microcontroller which is having a memory inbuilt on a controller or a chip is called as an embedded memory microcontroller. So examples: 8051 having a program and data memory, IO ports, serial communication, counters, timers, interrupts, etc. So these 8051 are embedded type of microcontroller. So next, the microcontroller is classified based on the instruction set. So there are two types of instruction set. One is RISC and another one is CISC. So what is CISC? CISC is nothing but reduced instruction set computer. These RISC are simple instructions taking one cycle for the executions. Very few instructions refers the memory and fixed format instructions. The RISC are a fixed format instructions and are executed by a hardware. The RISC have a very few and simple addressing modes. RISC architecture are highly pipelined. Example, the RISC are 8085 microprocessor and 4004 microprocessor. The RISC completely processed in the compiler. Complex addressing modes are synthesized in a software. The example, the RISC are hardware architecture. And so what is the hardware architecture and Princeton von Neumann architecture? We will see in the next slide. So for time being, the RISC are hardware types of architectures are Princeton. The RISC contains an instruction set that supports very few addressing modes. For example, it will takes a few addressing mode for performing the operations like a logical and arithmetic operations. And the RISC allows it simultaneously access the program and data, hence it is called as a pipelining, and which increase the execution speed, and which is allow each instruction to operate on any register to use any addressing mode. The RISC type of architectures or microcontroller which is having a smaller chip and pin count, and they are very low power consumption microcontrollers. So next see CISC. CISC is nothing but complex instruction set computers. The CISC processors have a large number of instructions, and a large instruction set helps the assembly the language program by providing a flexibility of writing a short and effective programs. The purpose of CISC architecture is to write a program in as few lines of assembly language code. For example, 8051 and the 8051 multiply. Short form, the instruction is MUL. It is complex instruction for which only the operands need to be specified in the instruction. The multiplication operation is to be done by hardware. The building of complex instructions in a hardware which helps the user into two ways. Firstly, the implementation becomes faster, and secondly, the program space required is less. Thus, the program operates at the higher level. The programmer requires few and simple fast instruction in a comparison to large complex and slow CISC instructions. However, it is obtained at a cost of writing more instruction to be accomplished to task with the help of RISC processor. The RISC having many instruction set and allows the programmer to be use one instruction in place of many simple instructions. The RISC type of instructions, they are refers more memory, most of the memories, and variable format instructions. The instructions are executed by microprocessor. The CISC architectures are many and advanced addressing modes, which is having many and advanced addressing mode. This is architectures are single register set, which is having no or less pipeline. The complexity of CISC processor is in microprogram. CISC architecture supports complex addressing mode. Here, some of the examples of the CISC type of microprocessor is Intel 8096 family. So let's see the family of the microcontroller. Before going to study the family of 8051 microcontroller, first let's see about what are the architecture of the computer. There are two types of architecture. One is hardware architecture and second one is one human architecture. So let's see first what is the hardware architecture. The hardware architecture is nothing but, here the figure shows the hardware architecture. The system architecture was designed to recommended by the hardware university. As per this architecture, the processor having a two different memory. So here they having a two different memory spaces with separate memory map. They are data memory and program memory respectively. Here see there are two different memory. One memory is specified for the program memory and another one memory is separately specified as data memory, which is having different memory map. the data memory and program memory having differently respectively. Therefore, the distinction between data memory and program memory in physical, it is connected to processor through separate set of the address and data and control bus. Each memories are interfaced to the processor by using a different data bus and address bus, and also different control signals. This type of architecture is normally used by the RISC processor. Here, see there are two different memories are here specified. This one is a program memory and this one is data memory. If I want to access the program memory, here instruction decoder which controls the this is a main unit which used to control the memory, how to access. First of all, the instructions will take the execution command and which access the program memory, read the instruction and decode the instruction, and after that it will interface to the processing register to process the data based on the instructions. These are having separate controls and data signals to access the respectively. The advantages of hardware architecture is simple constructions, less complexity because it's having separate bus structures, and allow size of data and program within the memory space to be adjusted, and flexibility and dynamically, which is very fine type of the architecture. So one of the disadvantages of the hardware architecture is also there. Being accessed by the same set of the bus, both program and data cannot simultaneously accessed. Here, both the data and program cannot be accessed simultaneously. This is one of the disadvantages of this type of the architecture. Let's see about von Neumann architecture. So what is the von Neumann architecture? Here this architecture was designed and recommended by the von Neumann at the Princeton University. As per this architecture, the processor is having a single memory space addressed through a single memory map. The memory may contain both data as well as the program in it. The distinction between the data memory and program memory is illogical. Therefore, same memory space shares the data as well as the program code. It is connected to the processor through a single set of the address, data and control buses. The architecture is normally used by the CISC processors. Here the block diagram shows the von Neumann type of the architecture. The memory interface unit which controls all the operations, how to access the program and data memory. So whenever the instruction decodes, it will give a command to the processor or register, as well as it will sense the address which memory has to be accessed by using address bus, and access the data respective memory by using a data bus, and the control signal using a control signal, what type of operation had to be performed. Either it may be read operation or it may be write operation. So these all operations are controlled by a memory interface unit. These memory interface unit which will control the operations of accessing the program and data memory. And after the accessing the data, it will send command to the processor to perform a particular operation. But here the memory having the same memory which is having a both program and data memory, here the operation will not perform parallelly, because if the data memory is accessing, then we can't access the program memory. Here only single memory can be accessed for a particular time being. So this is the main disadvantages of von Neumann architecture. Being accessed with the same set of bus, both program and data cannot interface simultaneously or cannot access simultaneously. But one advantage is here. The construction is simple, less complex bus structure, and allows size of the data and program within the memory space to be adjusted. And flexibility and dynamically is also provided here. But in their hardware architecture, they the memories exist by separate set. Both program and data can easily and simultaneously accessed there in hardware architecture, and improving performance also improve comparing one-in-one architecture. The implementation pipelining streamlined and decreases the CPU stalls, and so effectively increase the efficiency of the pipeline. So this is one of the advantages of hardware architecture. And one disadvantage of hardware architecture is two set of bus are needed and therefore relatively complex bus structure. So due to the existing different memory organization, the bus structure is complex there and do not allow the size of the data and program to be adjusted flexibility and dynamically, as they are stored in a different memory space as physically. So some of the example are Intel MCS51 family of microcontroller has a hardware architecture. This is because there are different memory spaces for the program and data and separate bus for the address and the data. The PIC microcontroller by Microchip also use the hardware architecture. So these are the small basic about the one-in-one hardware architecture. So let's see the features of the microcontroller. There are some features of microcontroller. Stop again. Before going to see the feature of 8051 microcontroller, we have to see about family of the microcontrollers. The 8051 family devices are classified according to their family. 8051 has a different Intel and Dolos, Philips. There are many different types of families there. So let's see few of them. A microcontroller family member has the same architecture and difference in the number of the pins and packaging mode. Here the microcontroller 8051 family has the architectures having same, which is having quite same features but different pins and packaging modes. The microcontrollers used in applications like a mobile phones, MP3 audio system, MPG processing, image processing, aerospace system, automated automobiles, and other high end of the embedded computing systems. So the overview of 8051 family, let's see how the families are classified. The Intel induced 8-bit microcontroller 8051 in 1981. It has 120 byte of the RAM and 4 kilobyte on-chip ROM with 2 timers, 1 serial port and 4 I/O ports on the chip. 8051 is an 8-bit Boolean processor. It indicates that it can operate on 8-bit data at a time. The 8051 has become popular after Intel allowed other manufacturers to make 8051 with the condition and that they remain code compatibility with 8051. This has led to different version of the 8051 with a different speed and on-chip ROM. All the versions are compatible with organized 8051. The 8052 and 8031 are 8051 family members. So what are the 8051 microcontroller? Let's see now. The 8051 8052 microcontroller which supports all the standard features of 8051. See, whatever the features of 8051 which supports all the features same in 8052 and which is having extra 128 byte of RAM. So except the data which is having extra 128 byte of RAM here having 8052 microcontroller and also extra timer also there. The 8052 has 3 timers and totally 256 bytes of internal RAM and which is also has 8 kilobyte of on-chip ROM. So 8031 microcontroller, let's see about small information about 8031 microcontroller. So 8031 microcontroller, it is called as ROM-less 8051. So which is having same features and architecture like 8051 except that which is having no or less ROM. This is because it's having 0 kilobyte of on-chip ROM. Hence, in order to use 8031, we need to add extra ROM to it. The extra ROM requires the program that 8031 will fetch and executes. ROM that can be attached to the 8031 can be as large as 64 kilobytes. 8031 loses 2 ports because of which is external memory is added. So due to the accessing external memory, we have connecting to 8031. So 2 ports are losing for the connection purpose. There are different 8051 microcontrollers are there. 8051 is generally not seen in a port numbers. It is available in different memory type like a flash, NVRAM, UEEPROM. Versions of 8051 is 8751. The flash ROM version is marketed by 80ml Corporation and Dallas Semiconductors. The 80ml flash 8051 is called as AT89C51 and Dallas Semiconductors calls them DS89. The NVRAM version is manufactured by the Dallas Semiconductors and it is called as DS5000. There is also an OTP. OTP is nothing but one-time programmable version is there. So which is made by various manufacturers. So let's see what is the 8751 microcontroller. The 8751 type of the microcontrollers which is having 4 kilobyte of on-chip RAM, that memory is UEEPROM, which is having 4 kilobyte of on-chip ROM. That ROM is UEEPROM. If this chip is to be used for the development purpose, then a PROM burner and UEEPROM eraser is required. As it supports on-chip ROM, it requires approximately 20 minutes to erase the 8751 microcontrollers before it can be reprogrammed. So what is DS89C4x0 from the Dallas Semiconductor, which is used to eliminate or need of the PROM burner? Dallas Semiconductor has introduced DS89C4x0 that can be programmed through the series of COM port of IBM PC. The on-chip ROM is a flash ROM and which supports on-chip loader and which is also support the program to be loaded into the on-chip flash ROM with the help of serial COM port and IBM PC. The in-system of program loading of DS89C4x0 through serial port makes it ideal home development system. So here another one, OTP version 8051. We will see some information about that. Some of the version of 8051 are one type programmable. The versions that are used for the product development are the flash and NV-ROM versions. The OTP versions of 8051 is used for bulk production in case where the product is completely designed and finalized. The price per unit is less. The 8051 family from the Philips is other major producer of 8051. Their products included analog to digital converters, extended I/O ports, and both OTP and flash. These are some features about, these are some basic information about the family, how they are classified, and different manufacturers. So let's see the next some features of 8051. The 8051 microcontroller is which is having 8-bit CPU and 8-bit arithmetic and logic unit, which is having 4 kilobyte of inbuilt ROM and 128 kilobyte of the RAM, which is having two 16-bit timer and counter. The 8051 microcontroller is a 16-bit program counter and data pointer is also having there, and 8-bit program status word is also used. So 8-bit program status word, which is having this having a total 8 bits, flags is there, group of flags is there, and also which includes 8-bit stack pointer and 64 kilobyte of external program memory and internal data memory is also there. Total there are 40 pins include in 8051 microcontroller. Within 40 pins, 32 pins are used for input output connection purpose. So on chip oscillator and clock circuitry also required for the microcontroller. Full duplex serial data communication and transmission facility is there with 2 external and 3 internal sources also provided, and which is having a powerful instruction set. Probably there are 111 instructions are provided in 8051 microcontroller. So these are some basic features of 8051 microcontroller. If in the examination, if they asked draw the block diagram of microcontroller with draw the block of blocks of diagram of microcontroller, then with the diagram we have explained some these basic features also. So this is enough for the day. So let's see further in the next class. Thank you.